right here. So for if I consider here, put here value of x positive. Okay, for x positive and small values, x positive and small values, or x positive and small values, okay, or for values of x positive and small, for x positive and small values, y will be here plus and negative, positive and negative, both positive and negative. Okay, this is positive and negative. And for negative values of x, a smaller value of x negative, y will be imaginary then, because x square root of q root of 3 by 2 cannot be calculated, it will be imaginary. And for x negative and small values, y will be imaginary. Y will be imaginary, not possible negative value which is there, because square root of this 3 by 2. Okay, we cannot calculate the negative value, square root of negative values. That means then y will be negative. Okay, so that means this positive and negative values. So first species of cusp will be there. In the one side of the y-axis, we will have a cusp. This is a cusp of first species will be there. So what is the nature character? A cusp of first species will be there. This is the final answer. Cusp of first variety, first species will be there, because in this case y is positive and negative values. If I take y is positive and negative, this kind of curve is possible. If I take x here, this is this, y is negative, y is positive. This kind of first variety, first species of cusp will be possible. But at this point, 2, 3 point, at 2, 3, a cusp of first species will be there. Okay, or will lie. This is what variety of cusp is there. Now let us take other points. Second question now. What is the second question? Let me talk about that. Okay, so question number second. Let me take. Now question second is, examine the nature of the double points on the curve. This again the same type of question. So let me take question number second here. So examine the nature of the double point. First of all, we consider that the curve fxy is given to us as x plus y whole cube minus square root 2. It is y minus x plus 2 whole square equal to 0. Let me take this as the first equation. This is the equation of the curve given to us. Okay, in second case, x plus y whole cube minus under root 2, we have taken to this side. This is function. Now differentiating it with respect to x, with respect to y, respectively, partially. Okay, so differentiate the solution we are finding out. Differentiating it partially with respect to x and y. I'm sorry, with respect to x and y respectively. So what do we get? We get del f del y del x. First let me find out. Del f del x, this one. This also can be differentiated. Okay, so first is 3 into x plus y whole square. But this bracket includes both x and y, but x again differentiated is 1, so it is only differentiation. Now in this case it is 2 square root 2 into y minus x plus 2, but minus will come out again. This minus x again differentiated is minus 1, so minus minus plus. This is the first. Let me take second equation. If I find out del f del y, what it will be, then it will be again the same kind. This is 3 into x plus y whole square. Again y differentiated is 1 positive. This is minus root. Now here it is y positive, so this is 2 root 2 into y minus x plus 2 only. Why y minus x plus 2? Because y again differentiated by is positive here, so plus 1, no difference of minus sign. Minus sign will be there still. This is third equation. Okay, so let me again differentiate. What are the x and y? We will just calculate solving these two equations. We have to equate them to 0, then solving them by adding and subtracting. If I add them, so x plus y equal to 0. So this is x plus y whole square, 6x plus y equal to 0, x plus y equal to 0. Then from this, if I subtract third from first, then y minus x plus 2 equal to 0, or y minus x equal to minus 2. In that way, after that we will solve them. Before that, let me again differentiate it. This is del square f upon del x square is equal to, this one is to be differentiated. This is 6 into x plus y plus, or this will be minus only, will be minus 2 under root 2 only. Why? Because minus x is differentiated. This is 0, this is 0, only minus 1, this is minus 2 root 2. Okay, this is fourth equation. Let me take fourth one. What about del square f upon del y square? So this is differentiated. Again, this is 6 x plus y only. This is also differentiated with 2 only. Y is differentiated as 1. This is minus 2 root 2, minus 2 root 2. Okay, so this is also negative. Okay, no problem. So this is negative. Okay, this is fifth equation. Now del square f upon del x del y. So this is del y is different with respect to x here. It will be 6 into x plus y. And this is with respect to x here, so it's minus 1, this is plus 2 root 2. Okay, so this is your sixth equation. Now let me equate del f del x equal to 0, del f del y equal to 0. These two equations will be there. First let me solve these two equations. What we have to do, if this is whole equal to 0, let me write here equal to 0, this is equal to 0. This equation equal to 0, this is equal to 0. If I add these two equations, this is plus 2 root 2, same value, minus 2 root 2, same value. If I add them, these two are cancelled out. This is 6x. So x plus y equal to 0 from second and third. Solving second and third. After equating them 0, after adding them. On addition, we get x plus y whole square equal to 0 and x plus y equal to 0. And on subtraction, if I subtract third equation from second, we will get y minus, this is y minus x plus 2 equal to 0. Only this y minus x plus 2 equal to 0. So these two equations are to be solved. If I add them, it will be twice y equal to minus 2, y equal to minus 1. If I substitute y equal to minus 1 here, x equal to 1. So only one point is possible, 1 and minus 1. Okay, but let me check whether this point is possible or not. If it is satisfying the given equation, so 1 and minus 1. The point is 1 and minus 1. We have solved. So 1 x value and minus 1 y value. This is a double point here. Now let me check whether this is possible. Double point. This double point 1 minus 1. Whether this is satisfying the given equation of the curve or not. Let me check it. So if I substitute this value here in the given equation, so left hand side is 1 minus 1 0. Okay, this is 0 here. Y is minus 1, x is plus 1, so it is 0 in the left hand side. The right hand side it will be y is minus 1, x is plus 1, minus 1 minus 1, this is minus 1 minus 1 minus 2 plus 2 0, this is also 0, so it's satisfying. So this is this double point. This point satisfies the given equation, satisfies the given curve. It means this point is lying on the given curve. That means this is the double point possible. So only 1 minus 1 is double point possible. Now let me check whether the tangents are distinct, tangents are coincident, tangents are not possible. Let me check that. At 1 minus 1, at this point, what are the values of del square f del x square, del square f upon del y square? Now let me write here. At 1 and minus 1, value of del square f upon del x square, from this value, this is 0. So it is minus 2 root 2. So this is the 1 x, y is minus 1, so this is 0. Second step is minus 2 root 2 only. And del square f upon del y square at the point 1 minus 1, at the point 1 and minus 1. What do we get here? This will be 1 and minus 1 here. This is again 0. The same value minus 2 root 2. Minus 2 root 2, this is possible. Minus 2 root 2, this value is there. Now del square f on del x square, this is 0. This is plus 2 root 2. This is plus 2 root 2. And del square f upon del x del y at the point 1 and minus 1, this is 0. First step is 0, this 2 root 2 positive value is possible. This value is 2 root 2 only. Now let us check whether this is positive or negative. So what do you mean by this? Del square f, this whole square, and multiply these two. I mean the same value is there. This means cusp will lie. Why? Because del square f upon del x del y whole square is equal to what? Whole square of this. That is 4 to the 8. This is 8 value only. And del square f upon del y multiplying these two. Del square f upon del x square into del square f upon del y square is equal to minus 2 root 2 into minus 2 root 2 positive value. This is also 8. So these two values are same. That means coincident tangents are possible. That means cusp will lie. So there will be a cusp at this point. Okay. Now this 1 and minus 1 point, let me find out what the cusp will be of first kind, of first species, of second species. So at 1 and minus 1 point, cusp is there because these two tangents are coincident. Tangents are coincident here. Tangents are coincident. Cusp will lie. Tangents are coincident. So tangents are coincident. Hence, what would be there? Cusp will lie. So cusp will be there. So this tangent, this double point is a cusp. Cusp will be there. Now let us discuss about what is nature of cusp. Shifting the origin to this point, 1 and minus 1, then what is the position of the tangents? What kind of tangents are there? Okay, tangents will be, cusp will be of first kind, of first species, second species. Let me check that. So shifting the origin 2. Here it is x plus y. Okay, shifting the origin to the point, double point, the double point here, 1 and minus 1. So what do we get? So we get here, this is, okay, here just neglecting this, we will get from this y minus x equal to 0. So this is the equation possible. Let me check this point here, because neglecting x cube and y cube and 2xy, that term and this term will be possible. So let me first write what is the value. So this is x plus 1 plus y minus 1. Because in place of y we have to write y minus 1, in place of x we have to write x plus 1. This same simple value, this is whole cube minus or equal to root 2. It is y minus 1 plus x minus 1. Okay, so this is plus 2 whole square. Y, in place of y we have to write y minus 1, in place of x we have to write x plus 1. So this is minus x minus x minus 1. Now in place of x we have to write x plus 1. In place of y we have to write y minus 1. In place of y minus 1, x minus 1. Okay, plus 2. This is minus 1 plus 2. This is y minus x only. Here it is x plus y whole cube equal to root 2 into y minus x whole square. Okay. So if I take, because this is the smallest value, y minus x equal to 0. Here y minus x equal to 0. Now if I take y minus x equal to, let me take p point here. Okay, what the position of p, for this is whole square. So equating this, neglecting x plus y whole cube, neglecting the two terms, let y minus x equal to p, we substitute here. We take this point here. So putting here y equal to p plus x in this equation. So what do we get? Y equal to x plus p. If I substitute y equal to x plus p, putting this in this equation, and we take this is 50 equation, 60 equation. So putting this value, putting value of y in 6th, we get, here we get y equal to x plus p. This is x plus p whole square in place of y. This is equal to under root 2 into p square only. Okay. Now if I open this whole cube, this is whole cube, I'm sorry. This is whole cube here. If I open this is twice x plus p whole cube equal to root 2 into p square. So from this value of p we have to calculate whole cube. If I open, it is 8x cube plus p cube plus 3 to the 6 xp, 6xp into twice x plus p. This is whole cube of twice x plus p equal to root 2 into p square. Let me further solve it. Let me solve it here. So what is the condition of value of p? If I open this, so we have to neglect pq here, but pq is neglected. Neglecting pq, we get here quadratic equation in p. What is quadratic equation in p? It is under root 2p square. Okay, p square will also come here. Okay, no problem. Let me write it. So it is 8x cube plus 6 to the 12. This is 12. Sorry. This is 12 x square into p or px square. Okay, 12, first one, 12x square p, 2 3 6, sorry, 6 2 12, plus p, so that means plus 6xp square minus root 2 p square equal to 0. I've taken this root 2 p square to left hand side. This is 6xp into p, that means p square, 6xp square minus root 2 p. Now let me assemble them in terms of p. So it's the quadratic equation in p. Put the value of p here. Okay, it is p square here. If I take p square common, it is nothing but 6x minus root 2 plus 12x square into p plus 8x equal to 0. This is quadratic equation in p. This is a quadratic equation in p. So we get the value of p, so equal to 0. So p is equal to minus 12x square plus minus under root. This 12x square, that means 144 whole square of this, b square minus 4ac. This is x4 here minus 4a into 4 is a 32. 4 is a 32 into 6x. Okay, this is 32 x cube within bracket. It is 6x minus root 2. Well, this is 4a into c. This is a. C is 8x cube is c. A is 6x minus root 2. A into c. 4a into c divided by 2 into a. That means 6x minus root 2. Now, what the value of p for value of x? Okay, small value of x, positive value of. Let me first further solve it. So, for value of x, we have to find out what is the value of p. So then, if it is different values, then there will be single species of first kind. Okay, if they are different, same values, then of second species. First, let me take for the p here. Further, if I take 4 common throughout, it will be 4 if I take common from this. So it will be 36 only. 36 into 4. Yeah. So 36x4 will remain there. Okay. Let me check. It is minus 12x square plus minus, I have taken 2 outside, means 4 outside. It will be inside 4. If I divide this by 4, 4 3 are 6, 4 3 are 12, sorry, 2, 4 6 are 24, 20, 36 x4 minus sign. This is 8 now. 4 8 is 30, so 8x cube into 6, 8 6 are 48 x4. Because x cube into x4, 6 into 8, 48, minus 48 into x4, minus plus here, plus 32 root, sorry, 8 into root 2, 8 root 2, because it was 8 only, 4 we have taken outside, 8 into root 2, minus plus here, plus 8 root 2 into x cube. This is the value here. So what about? Let me summarize them. This is 2 to cancel out now. This 2 and this 2. This is 6 now. This is 6x minus root 2. Okay, so value of p we are finding out. We assume y minus x equal to p, and then we are solving this. So value of p is the length of the perpendicular drawn from that point, that double point, to the given curve. Okay, so this p we are calculating. positive and negative. Let me take this is 6 here because 2 cancel out 2 and this is 6. So minus 6x square plus minus. Now inside we get this 12 only 8 minus 6 12. It is minus 12 x4 plus 8. It is plus 8 only. Yeah, it is plus 8 only. So while it minus 4 AC, yeah, it is plus 8 here. It is plus 8 root 2 into x cube. Okay, and if I take x square out, okay, out of this, then that will be possible. So x square, if I take common, is 6x minus root 2. So for positive values of x or a smaller value of x, this value will be greater because this is the smaller value we are taking. So 1 point, because x cubed is greater, that will be positive value. For that, plus minus 2 value will be possible of p. So p will be positive value. Here if I take, can I take 4 again? So 4 we can take outside. So 2 will come out, but no need of 2. If I take 2 common, let me take plus minus. This is twice square root. This is 4 we have taken, so this is minus 3 only, x4 plus 4 I have taken, so this is 2 root 2 x cube only divided by 6 x minus root 2. Now if I take x cube will be greater than x4. Why? Because this negative value minus 3 for a smaller value of this x, suppose 1.2 I have taken, so this value will be greater in that situation. This is smaller, so that will be positive value. So square root is possible. Let me write here. So for the smaller positive value of x, for the smaller positive values of x, positive values of x, okay, p will be, if square root is possible, then because this x cube, let me write here, value of x cube term will be greater than x4, this inside the square root. It means this value will be positive. So inside the square root will be positive. That means the two different values of p will be there. So p is different, or p will be plus minus here. So p is different. P is different, or positive and negative values of p. Negative value will also be there. So p is different, positive and negative, plus and negative values of smaller values of x, smaller and positive values of x, positive values of x. That means a cusp of first species will be there. So cusp of first species is possible. The two different values are there. So cusp of first species is there. So a cusp of first species on one side of the y-axis will lie. First species will lie on one side of the opposite side, or one side of the x-axis, sorry, y-axis, one side of y-axis. Okay, there is a cusp of first species. This is question number 2 we have done. Let me talk about question number 3. For the question number 3 here, let me talk about question number 3 now. It says discuss the position and nature of the double points again on the curve this. Let me take curve z let the curve fx by is equal to, we are given here, this is twice by plus x plus 1 whole square minus sine 4 into 1 minus x whole cube. This is 1 minus x here. Okay, so question number 3. Twice y plus x plus 1 whole square minus 4 into 1 minus x whole cube. Okay, now differentiating with respect to x and y. Solution we are finding out. Solution. So differentiating it, and take this is first equation equal to 0. Differentiating it with respect to x and y partially. So partial differentiation. Let me take del f del y del x first. Del f upon del x or del f with respect to x. Here we are differentiating. This is twice into 2y plus x plus 1 only minus sign. This will be 4 3 or 12 into 1 minus x whole square. Minus x is again differentiated with plus 1 minus plus. This is differentiation with respect to x. Again del f del y is equal to del f upon del y is equal to how much? Differentiating with respect to y here, this one. The first equation is to be differentiated. It will be 2 first, then 2 again, so it is 4 into twice y plus x plus 1 minus sign, this is 0. Only this value will be there. Okay, this is third equation. In the second equation we have taken again differentiating. So this is del square f del x square. This value is only x, so this is 2 only. First one is 0, this is 0. And what would this? This is minus sine 12 to the 24 into 1 minus x only. Okay, this is differentiation of this. This is x1 and twice 2 into this. Okay, so this is, let me write it again. This is 24 into 1 minus x. No problem. Now, del square f upon del x del y is what?